I figured I'd put up another movie. What the heck? I watch this stuff every day, and actually, I pull up all this stuff in the morning and in the evening just to see what's going on. And it hasn't looked too good, but it doesn't justify a movie every day, I don't think. Or you guys would be totally bored with me. But anyway, here's the latest MLSO run for the K-Core NRGF data for today. It used to be they were running in 1 minute increments. Now they got it down to 2 minutes. That happened a few days ago, and it's continued. So that makes these shots less dramatic, I would think, in my opinion. Got a few missing frames here coming up. There you see them from 32 went to 50. So that's like 9 frames. Yeah, that would be 18. Yeah, 9 frames. So who knows what was in there. I'll have this thing cleaned up by tomorrow. Guaranteed. At least that's been their modus operandi. I pulled up, like I said, I pull this stuff up every day. The one yesterday was good. It had 87 frames. They might even have been in 1 minute increments. I'm not positive. Well, let's pull it up and look. Stuff was flying all over the place. I guess it tells you here. Probably didn't have to pull it up. Oh, I just pulled up today's again. Darn it. Hang on a second. Yeah, yesterday I was 26th. They give you the 2 minutes cadence. So it used to be a minute. So this is yesterday's, and there was stuff flying all around before they cleaned it up. Just like the one I'm showing you today, quite similar to that. This is what this one for today is going to look like tomorrow. I'll clean it up. You can still see some stuff though. In fact, you can see some stuff better after they clean it up. But I think they're fudging around with this resolution on some of these objects, which we've seen or noticed. Ooh, maybe a month ago when I first started, a couple weeks anyway, when I first started pulling up these K-Core images. But anyway, that's the sanitized version. Here's the raw version, but with some frames missing. So no telling what they scrubbed out on that. All right, this space weather's starting to look pretty, a little bit, to me, a little bit scary. The radiation belts aren't showing a whole lot, but watch these arrows. When they're pointed away, they should be pointed away from our planet in order to, well, the solar wind coming from our sun is naturally going from right to left on this computer simulation. But there's something back here, and it's really starting to put some pressure on the back side of our magnetosphere, which is causing our magnetosphere to have to develop a secondary bow shock behind the planet. And I'm not sure how much longer this is going to hold. Like I said, I pulled this stuff up this morning, and I just didn't feel like making a video. But there was all this blue energy is all negative plasma energy, electrons coming from, I would have to assume, Nemesis. Look at all this pressure. But anyway, this morning, okay, there it is there. See how the blue's starting to build up in front of the planet? It's building up along these closed field lines, red closed field line. And you could really see it on this Y-cut model too this morning. I mean, it was bright blue, back and front, trying to ward off this extra solar pressure, and the solar pressure, this extra pressure from behind, and it seemed to be coming in from up around this area stronger, because this stuff was shifting up to meet it. You could see it tilting. The pressure was showing up here more, and that I think was causing this electron pressure to, or electron plasma to sneak in. So we were getting some serious buildup along these closed field lines that are tight to the planet, these red ones. Anyway, I pulled up the geospace. You can see here, this gives you density. See, we got a whole bunch of solar wind pressure coming from the sun, because these ones are reversed as opposed to the ISFO ones I showed you. The sun's on the left on this simulation. And look at all the solar wind pressure. This denotes density, the color. So when you see a high density, a lot of this magnetopause or magnetosphere gets sort of disappears on this model anyway. This shows you the velocity. It's really kind of hard to read this one, but you can see it got some funky stuff going on here. Wait till it flips back around. Okay, yeah, right around 18. See how it's like dancing? And this is when all that density pressure is coming in. Oh, come on. Watch this density pressure coming in from the sun side, which I'm going to show you ACE, and ACE does not comport to this type of solar wind pressure. See how it's dancing around? And anyway, and then this last one down here shows pressure. You could see we have a lot of solar wind pressure coming from the sun side. And this is what I'm talking about. See how there's more pressure up on the top here. Oh, you can see it building there. The deep red colors. That's all solar wind pressure coming from behind the planet, which should not be, guys. Should not be. Here's ACE, like I showed you numerous times. It's parked 1.5 million kilometers directly between Earth and the Sun at the Lagrange 1 point, and I'll put the links in the description box. You can look it up. And of course, we got the missing data. Missing starts around 12:30 or 0:30, just after midnight, and it runs up to 7. So that's a smaller gap. We saw 9-hour gaps, 8, 9-hour gaps most recently. Even yesterday, I believe I seen a 9-hour gap, which I was starting to wonder what the heck. Anyway, there's a phi angle that looks like, and I'll put the tutorial down there so you can read about the phi angle. It indicates what the electromagnetic connection is between our planet and the sun. When it's at 180, that means the sun is pretty well locked onto the Earth electromagnetically, and the connection's coming from the sun to the Earth. When it's at 0, the connection's coming from the Earth to the sun. There should be nothing above the 180 mark. That indicates some type of connection or electromagnetic influence or interference coming in from behind the Earth. These ones, these BZ, BTs, I don't know how to interpret those. There's the density. The density wasn't that high. See what I'm saying on ACE? Solar wind pressure never really got much above 440, if that, except for a couple of these little blips. And the density is very low. See, they have these scales dialed way back down. Usually it's in 100 increments. It goes up to like 600 or something, at least 50 increments, but not 20s, increments of 20. So, like I showed you on that geospace one, and on this, you can see it too. Here's the solar wind. Now, these solar wind numbers and all these computer simulations are generated from GOES satellites that go around the Earth in a geosynchronous orbit, which is only 22,236 miles above the Earth, as opposed to the ACE satellite, which is way out here, 930,000 miles between the Earth and the Sun. So that's like 900 some thousand miles in between this ACE satellite and this geosynchronous GOES satellite. So I showed you on ACE that the solar wind never got above 440, right? For any of these runs. But look at it here. This measures the solar wind speed on these GOES satellites. And it's all over the board. So we're getting a lot of fluctuations. But I mean, there has to be some other, between the 930,000 mile ACE satellite out here and the 22,236 GOES satellites, there has to be some other type of solar body coming in here and pressing or emitting some type of a solar wind in order for this thing to be going haywire like it is. And it's always above 440. I mean, it goes up as high as 7. The other day, I think it was last night or the yesterday morning, I saw it go up to 906. And I never seen it go above 900. 800 rarely, but it went above 900. So I don't know. I can't explain it unless there's more than one sun, or unless somehow the tentacles from Nemesis, sometimes they wrap around and produce a solar wind that comes in around the front, because solar wind comes in more strongly when there's a direct electromagnetic connection between the Earth and our sun, for instance. That's when we get a stronger solar wind, especially when there's a coronal hole involved. So that's what I suspect might be happening out here in front. We got some kind of a Nemesis has to be back here somewhere. I think it's up here. See how the pressure's coming from this side, top left on this simulation. So I think Nemesis got to be somewhere up around in here, but it's got a magnetic connection coming around, connecting to Earth in the front sometimes, and that's what's driving this solar wind. Maybe these solar wind numbers crazy, because it's being read by these satellites that are going around the planet. That's all I can figure, unless it's picking up some of this solar wind. Now this could be it, since these things operate with inside the magnetopause. Maybe, just maybe, it's picking up solar wind pressure that's coming from behind the Earth, and which is leaking in past our faux bow shock that Earth had to try to develop behind the planet to keep this stuff out, and sometimes maybe even wrapping around and coming in, like I showed you here with this blue. That's wrapping around and coming in from the front. So maybe that's what's driving some of these numbers. Maybe it's all coming from back here and there is nothing out in front, because I never seen anything about having more than one sun, except for the stellar core crapola from Dr. Claudia Albers. I don't even think she's a physicist, because I've looked at some of her work and she was unable to even identify common things that were on, like in a octagonal occlusion disk on that one satellite that they were making such a big deal about. Anyway, I'm running out of time. That's about all I got for today, guys. God bless, peace, and I'm out.